I'm Luis Anthony Ast, the Video Math Tutor, and welcome to Basic Math Lesson number 4, Properties of Numbers. Let's get started. All real numbers, variables, and algebraic expressions follow certain properties. Yeah, they can be pretty obvious or a little complicated. What I hope to do in this lesson is present these to you in a very concise way and provide you some certain examples when necessary. When explaining these properties, I will use the variables a, b, c to represent my numbers, or my variables, or my algebraic expressions. Now, for simplicity, I'll just say number, or just value. The reflexive property of equality. A number is equal to itself. Symbolically, this is what we mean by that. A is equal to A itself. Another way of saying that as well, it's like saying 2 is the same as 2. Or, like 3 is the same as 3. It's pretty much the gist of it. This is a very simple and obvious rule, but it's also very important. In algebra, when you have to check your word problems, you're not done until you get a statement that actually looks like this. A equals A, 2 equals 2, etc. So it's good to know this. The symmetric property of equality. If one value is equal to another, then that second value is the same as the first. Symbolically, we can just say if A equals B, then B equals A. That's why it's kind of symmetric. It's switches around and it means the same. Now, why do we need to know this? Well, again, we're going back to word problems. You may be doing a word problem and all of a sudden you get an answer that looks like this: 3 equals X. And that's fine. But traditionally, for a final answer, you want the X to be on the other side. So because of this property, I am allowed mathematically to just switch places. The transitive property of equality. If one value is equal to a second, and the second happens to be the same as the third, then we can conclude the first value must also equal the third. Symbolically, this says if A equals B and B is equal to C. See, the word transitive is like transits, it's traveling. A, it will do what? A is equal to C. The substitution property. If one value is equal to another, then the second value can be used in place of the first in any algebraic expression dealing with the first value. Another way of seeing this is that if A equals B, then B can be substituted for A in any expression dealing with A. And we can actually change this around. If A equals B, then A can be substituted for B in any expression dealing with B. You might be going, what? Well, in a nutshell, we're just substituting one set of values for others. And again, this will be done in more detail in our algebra sessions. The additive property of equality. We can add equal values to both sides of an equation without changing the validity of the equation. To see this rule, all we got to do is say, well, if A equals B, we can add the same thing to both sides of the equation. It's not going to change it. So I can actually add, let's say, a C. So I'm going to have A plus C equals B plus C. And this actually represents the same thing as just A equals B. We can go one step further. We can actually switch these around. This is also a true statement. I can say C plus A equals C plus B. So you can add on one side or the other side, it doesn't matter. Same thing. I want to stress this is actually one of our most important properties of numbers. We can add The same thing both sides of the equation. When we start solving algebra equations, this is one of the main things we do. The Cancellation Law of Addition. We can subtract the same thing from both sides of the equation. So if you have something that looks like this, looks familiar? We can actually get rid of the c's by subtracting them. So officially you're going to go minus c, so they actually cancel. So the final answer is just going to be A equals B. The multiplicative property of equality. We can multiply equal values to both sides of an equation without changing the validity of the equation. If A equals B, I can multiply both sides of the equation by something, let's say C. I can go A times C equals B times C. That's a very handy rule. And again, the variables are just next to each other. That means implied multiplication. And we can also switch these around and state C times A equals C times B. Same thing. The Cancellation Law of Multiplication. To see this law, let's say if A times C equals B times C, and we want to cancel the C's, what can we do? Well, assuming C is not 0, we can actually divide both sides by C, and that would cancel them out. What would you be left with? Just A equals B. The zero factor property. If two values that are being multiplied together equal 0, then one of the values, or both of them, must equal 0. If A times B equals 0, what can we deduce from the situation? Well, A is equal to 0, or B must equal 0, or both of them must be 0 to make this situation true. We could also reverse the scenario. If A equals 0 to begin with, or B equals 0 to begin with, then when you multiply the two variables together, A times B, the answer must be 0. So notice how we switch this around. If we have two things times each other equals 0, one or the other is 0, but if you know one or the other is 0, then their multiplications must be 0. That's all what this rule says. The law of trichotomy. For any two values, only one of the following can be true about these values. They are equal. The first one has a smaller value than the second. The first one has a larger value than the second. Symbolically, what does this mean? Well, if you're given any numbers, A and B, only one of three things can happen. A can be equal to B, or A is less than B, or A is greater than B. The transitive property of inequality. If one value is smaller than a second, and the second is less than a third, then we can conclude the first value is smaller than the third. Well, we learned earlier the transitive property of equality, but there's one for inequalities, and it's as follows. If A is less than B, and B is less than C, we can transit A over here and state that A is less than C. There are four rules we need to be aware of when dealing with absolute values. Rule number one, all absolute values are non-negative. In other words, they're 0 or they're positive. Rule number two, the absolute value of the opposite of a number is the same as the absolute value of the number. It doesn't matter. Let's look at the other two rules. Rule number three, you can multiply the numbers inside the absolute value, or you can take the absolute values of the individual numbers first, then multiply them together. Rule number four, so long as B is not 0, can't equal 0, because you can't divide by 0, right? You can divide numbers inside the absolute value bars, or you can take the absolute values of the numbers individually at first and then divide them. Closure. The closure property of addition. When you add real numbers to other real numbers, the sum is also real. Addition is a closed operation. Symbolically, all this really means A plus B equals a real number. If A is a real number and B is a real, the answer's got to be real. The closure property of multiplication. When you multiply real numbers to other real numbers, the product is a real number. Multiplication is a closed operation. Similarly, with multiplication, A times B equals a real number. So if A is real and B is real, the result is real. I like to state that the real numbers are closed with respect to addition and multiplication. What does that mean? That means if you add or multiply real numbers, the result is also real. Now you might ask, well, isn't that always the case? Is it pretty obvious? Well, no. There are situations where you don't get a closed system. For example, subtraction with natural numbers. Let's say, we're given 3 is a natural number, right? And 5 is also a natural number. What if I subtract these two? What happens? Well, 3 minus 5 is a -2. And -2 is not part of the set of natural numbers. So it's not closed. To be closed, it should be natural, natural, natural number. Didn't happen. So that's an example that doesn't work. Commutativity. The commutative property of addition. It does not matter the order in which numbers are added together. The commutative property of addition is actually pretty straightforward. What it says really is that A plus B is the same thing as, switches around, B plus A. Doesn't make a difference. The commutative property of multiplication. It does not matter the order in which numbers are multiplied together. All this property says that if we have A times B, that's exactly the same as B times A. Associativity. The associative property of addition. When we wish to add 3 or more numbers, it does not matter how we group them together for adding purposes. The parentheses can be placed as we wish. All what the associative property of addition means is I can associate or group together 2 of the terms, add them up, then add the third. Or, see, I can associate these in a different way. I can put the last 2 together first, like this. I'm associating now these 2, add them up, and then finally add the first with this result. The associative property of multiplication. When we wish to multiply 3 or more numbers, it does not matter how we group them together for multiplication purposes. The parentheses can be placed as we wish. So now we get to do the same thing with multiplications. I'm associating the first 2 terms, I multiply them together, and then that result will be times the third. Or I can associate, group together a different way. I can make it the second and third terms, multiply them together first, and then times it by the first. In any case, you get the same result. By the way, I just want to let you know that the commutative and associative properties do not apply to subtractions and divisions. If you don't really believe me, go ahead and give it a try. Identity. The identity property of addition. There exists a special number called the additive identity. When added to any other number, that other number will still keep its identity and remain the same. Symbolically, we would say a number plus 0 is just a number. It kept its identity. And it'll work the other way around. I can put the 0 first and say plus a number is just a number. The identity property of multiplication. There exists a special number called the multiplicative identity. When multiplied to any other number, then that other number will still keep its identity and remain the same. Of course, no big surprise, this also works for multiplication. A number times 1 is just a number. The number kept its identity. And like before, if we switch these around, you still get the same result. I want to take a moment to stress that 0 is the unique additive identity. It's the only one that works. And 1 is the unique multiplicative identity. Okay, don't confuse the two. Inverse. The inverse property of addition. For every real number, there exists another real number that is called its opposite, such that when added together, you get the additive identity, the number 0. Symbolically, if a is a number and you add what we're going to call the additive inverse, or its opposite, the answer is 0. And if you switch it around, you get the same result. If you have the opposite of a number plus the number, the answer is 0. And I want to make a special note that, again, when you see something like this, negative a, it really means the opposite of a, the opposite of the number. And it's also called the additive inverse. The inverse property of multiplication. For every real number, except 0, there is another real number that is called its multiplicative inverse, or reciprocal, such that when multiplied together, you get the multiplicative identity, the number 1. Symbolically, we can say that a number times its multiplicative inverse, which is also known as a reciprocal, 1 over a, the result is the multiplicative identity, 1. So let's put that here. And we can switch things around. The reciprocal or multiplicative inverse of a number times a number is, yep, you guessed it, it's also 1. By the way, there is one number that doesn't have a multiplicative inverse. Do you know which one it is? It's 0. Well, why? Well, it's actually pretty easy to see. The reciprocal, so you switch it around, so if you flip around 0, you would get something like this. 1 divided by 0. And there's a rule of mathematics that says that you can't divide by 0. This is considered undefined. So 0 has no multiplicative inverse. Distributivity. Try saying that 3 times as fast. Distributivity. I can't. All right, let's get started with the lesson. The distributive law of multiplication over addition. Multiplying a number by a sum of numbers is the same as multiplying each number in the sum individually, then adding up our products. Now, distributive property is going to be our most important property of this entire lesson, so let's spend a little more time with it. Let's do an example first. I want you to look at this thing. 5 times quantity 7 plus 3. If you want to simplify this, what would you do first? Well, I'm supposed to, according to our order of operations, which was the previous lesson, we add up the 7 and 3. So 5 stays by itself, and you're going to get 10. 5 times 10 is 50. Now, when you take a look at this situation over here, I have 5 times 7 plus 5 times 3. Let's simplify this. 5 times 7 is 35. 5 times 3 is 15. If we add those two up, you get 50. So the results are the same. So if you look carefully, what's happening here versus here? How can I make them, they're supposed to be the same, how can I make them the same? Well, if you look carefully, this part right here can be derived by looking at this and say, well, I'm going to 5 with the 7, and then the 5 with the 3. I'm distributing. I'm spreading out the 5 amongst all the numbers in the parentheses. Yes, that's where we get the property name from. And we get this, and it turns out the answer is the same. So now let's take a moment to formalize what I just said. Symbolically, we can see this as A times a quantity, B plus C, is equal to A times B plus A times C. Again, this is implied multiplication. The way to remember this is, again, I'm going to distribute the A. So A goes times the B, and then A goes times the C to get this. And throughout my many lessons, I hope to actually do these little arrow things to remind you of the distributive law or distributive property. I just want to also let you know that this is also called the left distributive property because the A that's being distributed is on the left-hand side. The right distributive property means that if we have something that's on the right-hand side of a sum, I can distribute it like this. And when you do that, see, C times A is AC, C times B is BC. That's all there is to it. The distributive law of multiplication over subtraction. Now, since any subtraction is really an addition, the distributive property also works for subtractions. And here's the way you can symbolically represent that. And A times B, there it is, and you see with A times C, and you subtract the 2. The general distributive property. We don't have to have just 2 items within the parentheses. You can distribute over any number of items in a sum. So in this case, I can distribute the 2 to the 1, the 3, the 5, and the 7. What will this give us? Well, 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10, and 2 times 7 is 14. If we add those up, we get an answer of 32. Symbolically, we could represent this as something like this. This A is going to distribute amongst all these terms. Again, I don't know how many I have, so I just call it, n terms. So you distribute, and you get something that looks like this. A times B sub 1 plus A times B sub 2 plus A times B sub 3, and so on until we eventually get to the nth term, which is going to be A times B sub n. The negation distributive property. If you negate, or find the opposite, of a sum, just change the signs of whatever is inside the parentheses. For our last property, if we want to negate a sum like this, all you can do is, if you have A, you write down the opposite of A, which we talked about earlier is, you say negative A or the opposite of A. And B, its opposite is right here. Now let's just simplify this, and it becomes right here. Negative A minus B. So in a nutshell, all you're really doing is just changing the sign. So whatever's over here, if it's positive, you make it negative. If it's negative, you make it positive. And that's a very easy way of seeing this rule. Now, again, you could also think of this as a negative 1 that's being distributed to these 2 terms. For quiz question number 1, we want to find the additive inverses of these numbers. Let's go ahead and do that. So the additive inverses are the opposites, so the signs change. So this is negative 5, we want 5. 2/3 would be negative 2/3. The additive inverse of negative 1 is 1, and the additive inverse of 0, oh, this one's a little bit sneaky. You don't say negative 0, just say 0. For question number 2, we want the multiplicative inverses of actually the same numbers we had for question number 1. Let's go ahead and do that. Multiplicative inverses are the reciprocals. So numerators become denominators, denominators become numerators. If you have whole numbers, just imagine it's negative 5 divided by 1. So its multiplicative inverse is negative 1/5. 2/3 would be 3/2. Negative 1. What's that? It's actually itself. you don't put it over 1. And now, this one's a little sneaky too. What's the multiplicative inverse of 0? Well, we talked about that earlier. It doesn't have any. So, none. Don't have any. Question number 3 asks, what is the additive identity? The answer is, of course, 0. Question number 4 asks, what is the multiplicative identity? 1, of course. Question number 5. Do all numbers have an additive inverse? The answer is yes, they all do. Number 6 asks, do all numbers have a multiplicative inverse now? Well, no, 0 does not. For question number 7, I want to complete each of these equations by filling in the box with what is necessary to perform the property that is asked for. So for the first one here, I want to use the additive inverse. So if I have a negative u plus u, well, the answer is just going to be 0. How about over here? 8 times 7, I want to use the commutative property of multiplication. Well, that just means switch it around. So our answer is going to be 7 times 8. Over here, I want to use the distributive law. So what can we do? Well, we're going to distribute. Pretty easy. So I get 5w minus 5y. And for this one here, I want to use the associative property of addition. So here I'm associating these two, so now I need to associate the first two. So it's going to be something that looks like this. Let's do some more. For the next one, I want to use the reflexive property of equality. So z is equal to itself. That's what it's all about. So just write down a z. And over here, if a is not less than b, a is not equal to b, therefore, according to the trichotomy property, what must be the case? A is greater than b. Question 8 asks to identify the property that's being illustrated by these examples. The first one here, we have m times 1 over m. So we have something here, multiplication is going on, and that's a reciprocal, or the inverse. So this is the inverse property of multiplication. For this next one, since square root of 3 and e are real numbers, so is square root of 3 plus e. What property is being illustrated here? Well, we're stating that these are real numbers and so is the sum. So that's just the closure property of addition. For this one here, what's going on? We have 2 plus x squared equals x squared plus 2. This has been switched over. So that's the commutative property of addition. Continuing, look at this one over here. Well, it looks like I'm associating two things here, not the third. Here I'm associating the last two, not the first. That's the associative property of addition. Let's look at this one over here. I have y times 1 is y. Well, which property is this? Well, it's just the identity property of multiplication. How about this really long thing here? If x equals y and y equals 5, then we can conclude x equals 5. Well, that's the transitive property of equality. Let's look at the next one. Square root of 2 plus 0 is square root of 2. See, it stayed the same. It kept its identity. So that's just the identity property of addition. For this last one here, I'm negating something, or I'm distributing a negative sign. And all what's really happening is I'm changing the signs of the terms that are the inside of the parentheses. So that's just the negation distributive property. Question number 9 is just like number 8, but these are a little bit sneakier or a little bit more difficult or intimidating looking. But if you follow the property rules, it should be fine. For this one here, what's going on? Well, this is staying the same 2 plus x, x plus 2. Okay? It's the commutative property of addition. For this one here, the quantity A times B is then times C, or I have the quantity B times A times C. And I think, oh, this parenthesis, this must be associative. Well, no, because I'm not changing my association. A's and B's are still A's and B's, but they've swapped places. Oh, well, that's the commutative property of multiplication. This one here, let's go over here. Watch very carefully. What's going on here? I'll get a 2 and an x minus 1, and then we have a y times this whole thing, and then the y is here and here. Oh, I've spread the y out. So this is just the distributive law, or specifically, you can say it's the right distributive property. The y distributes, and it's on the right-hand side. Now for this last one here, what's going on? Again, looks pretty nasty looking, but it's really straightforward. We have 1 over x squared plus 4, and we have x squared plus 4 over here. 1 over something, I think about reciprocals. So, and then the answer is 1. So what do you think is happening here? What property? It's the inverse property of multiplication. These next two are a little tricky. In fact, this one here is probably the #1 question that appears on exams, where the professor, if he wanted to just try to trick you, make you think about the rules. A lot of students fall into the trap. So you gotta look at this very carefully. People say, hey, there's parentheses here and there's parentheses at the end. Must be the associative property of addition. Well, is it? See, I want you to look at it very carefully. This is associative property. I first group 2, and then I group 2 different. See, the x plus y is still being grouped together. But it appears first, and then plus z, and here the z is first, and then x plus y. So this is really the commutative property of addition. Very sneaky. For this one, there's actually, I can think of 2 different answers. So if you get either one or both right, you're fine. For the first one, well, it's the identity property of multiplication because 1 is the multiplicative identity. But 1 is its own reciprocal, its own inverse. So this is also the inverse property of multiplication. Now, for the next one, I have 5 plus w plus a negative w, or opposite w, equals 5. See, these are canceling themselves out. So what's happening here? It's the inverse property of addition. Okay? And then this last one here, again, looks rather elaborate, but notice everything is staying in the same order. 2a, b, c, 2a, b, c. So it's not commutative property. Commutative, you swap things around. So here I'm associating 2 things, and then associating 2 things, and over here I'm just associating the middle items. So this is the associative property of multiplication. A rather strange variation of it, but that's what it is. This next question, well, it's the only one that we know that has absolute values on it, so it's just property of absolute values. Well, specifically rule number 4. For the next one here, look what's happening. We have a couple of things multiplied together. See what happens? We have x plus 1 times y, x plus 1 times 2. See, we are distributing this x plus 1 to the y and also to the 2. So it's just a distributive law of multiplication over addition. For this last one here, well, it's pretty obvious. It's just 1 times something is something, so that's just the identity property of multiplication. But see, it's also a little sneaky because it's also something else. You can think of this as 1 times the y, 1 times 2. So it's just a distributive law of multiplication over subtraction. Question number 10, we want to use the commutative property to rewrite each of the following expressions. So let's start with the first one here. So x plus 5, to commute, we switch it around. So that one's pretty straightforward. How about the next one? P times q, switch it, Q times P. Now this one here is a little tricky because there's actually several ways of doing this. One way, well, the obvious one, I can just switch this around. So you're going to get 8 plus 2y. What else can we do? Well, you can actually just swap these two, because that's multiplication. So this is the same thing as y times 2 plus 8. And how about another way? How about let's swap these two around? So last one I can think of is that one. For this last one, again, we're going to need to be careful. I cannot just swap these around because the commutative property does not apply to subtraction, but it does apply to multiplication. I can switch these two, so the 2 stays. So you get that. Question 11 asks us to use the associative property to rewrite each of the following expressions. So for the first one, the last two have been associated, so we're going to just shift this around here and put it with the first two. That's pretty straightforward. How about this one? Well, again, it's with the second two, so we're going to put it with the first two. Times the z. And that's all you need to do with this problem. For our last question, we're asked to use the distributive law to rewrite and simplify each of these expressions. So let's start with the first one here. Negative 2 is going to distribute with the x and the 3. This is going to give us negative 2x plus, again, just to show all steps, it's negative 2 times 3. And that's equal to negative 2x minus 6. That's all you got to do for that problem. So now we want to negate this subtraction here. So I'm going to distribute the negative. So you're going to get negative 2y minus, again, just to show the steps, minus a negative 9. And when we simplify this further, we get negative 2y plus 9. Of course, we could have done this much faster by just changing the signs of this thing. This is a positive 2y, negative 2y, minus 9, plus 9. Same thing. Well, we've reached the end of this lesson. Whew. I hope I was able to help, but if you have any questions, please don't hesitate to email me at this address right here below. And with that said, this is Luis Anthony Ast saying, keep studying. Bye-bye.